Of all the systems humanity has disrupted, the climate system is probably the most consequential for our own well-being and that of the biosphere. Climate is a statistical portrait of weather that's painted over decades and centuries.
Today, that portrait is being altered at a rate and magnitude that are unprecedented in human history. As a result, climate change has become the public face of the Anthropocene throughout most of the world. It represents, like nuclear war, an existential threat to human civilization and to the biological diversity of this planet.
The new abnormal in climate is basically the new normal in extreme weather. Climate can be defined as the average pattern of weather prevailing over a long period. It includes rainfall patterns, temperature fluctuations, changes in wind velocity, relative humidity, and shifting evaporation rates. It also includes days of dazzling sunshine and earth-tilted seasons that add immensely to our fun and adventure. Powdery snow flying beneath a snowboarder's feet reflects radiation from the sun back into space. But not for long, because winter is warming in most of the world and ice and snow are in retreat. They're replaced by darker seas, soil, and plants that absorb increasing amounts of solar energy, thus adding to global warming. The ocean is slowly rising, but at a faster rate now because of accelerated melting of land ice and the thermal expansion of warming seas. Almost everywhere, extreme weather events increase in frequency and intensity. Most of the climate disruption is caused by enhanced greenhouse gases, a case of humans overloading the Earth's beneficial greenhouse effect by powering our economies with massive amounts of coal, oil, and gas, and by replacing forest and natural lands with human settlements and enterprises that are much more lucrative. The forest we convert into piles of dead timber reduce our planet's ability to sequester or absorb many greenhouse gases through the natural processes of photosynthesis and nutrient ingestion. Moreover, much of the cleared land is used to raise livestock, which feeds billions of people but contributes heavily to global atmospheric emissions of carbon dioxide, methane, and nitrous oxide. These anthropogenic greenhouse gases are fast becoming alarming signatures of the Anthropocene. They form a global blanket that traps heat in our lower atmosphere and thereby sets in motion a massive series of long-term changes in climate. When the Industrial Revolution began, carbon dioxide made up only 280 parts per million by volume of our atmosphere. Today, it is well over 400 parts per million and growing fast. The heat-trapping ability of this gas and other greenhouse gases has already raised global average temperatures by nearly 1 degree Celsius, and without major action on our part, temperatures could increase by as much as 6 degrees Celsius by the end of this century.
Of course, an increase of only a degree or two sounds like nothing. But think about your own body temperature. Very small increases can make the difference between being healthy enough to run a marathon and being confined to bed with a fever. An increase of 6 degrees Celsius, if not quickly reversed, would result in organ failure and death in a very short time. The impacts of this rise in mean global temperature are already disrupting the lives of billions of people and producing hundreds of billions of dollars in damage cost annually. Extreme storms, wildfires, flooding, heat waves, rising seas, health threats, crop losses, and dozens of other effects are well documented across the nearly 200 nations that signed the Paris Climate Agreement in December of 2015. But perhaps the single greatest impact is not even acknowledged by most people, and that is the massive threats to habitat and wildlife posed by abrupt changes in many climate subsystems. The rise in sea surface temperatures, for example, spell catastrophe for many of the world's coral reefs, just as the increased melting of Arctic sea ice may devastate polar bear populations. Small changes that happen fast are generally more threatening than big changes that happen slowly, because most plants and animals can adapt if they have time.
The idea that very small causes can have very large effects lies at the core of the climate debate. For most people, this is simply counterintuitive. Big changes must have big causes. But scientists know that this is false. Like the famous butterfly effect in chaos theory, a small stone dropped in a very large pool can have major ripple effects far away. In other words, vast nonlinear effects can be caused by tiny changes in system properties, and the properties themselves can be microscopic. The Spanish flu virus of 1918 was one of the smallest disease organisms in the world, but it caused up to 100 million human deaths. Basically, today's climate threat is caused by minute increases in the atmospheric composition of CO2 and other greenhouse gases. The CO2 added by humans amounts to an increase in concentration of about 1/100%. This means that climate changes unleashed during the past 100 years stem from an increase in atmospheric carbon of only 100 parts per million, equivalent to adding one piece of straw to a camel's back that already supports 10,000. Like the camel, climate systems can fail due to the cumulative effect of tiny changes. Small as these accumulations are, they may soon push the Earth's climate past critical thresholds, possibly leading to a massive loss of Amazon rainforest, Arctic sea ice, and glaciers in the Tibetan Plateau that collectively provide water to nearly 2 billion people. Many other outcomes, some irreversible, may emerge in the form of habitat loss, coastal flooding, crop failures, and the global expansion of disease vectors. The extreme events and climate surprises lurking in our future will surely add instability and uncertainty to key social and environmental systems. Conceived as a system of systems, the Anthropocene's chief subsidiary appears to be the climate system. No other internal system seems to influence the other systems with as much disruptive power. If it had not been for the discovery of fossil fuels and their combustible influence on climate, it is unlikely that the Anthropocene would have even emerged as a topic at this point in human history. Surprisingly, the role of climate change in ushering in the Anthropocene may have actually preceded the use of fossil fuels. Forest, rather than fuels, appear to have been the critical factor. One prominent theory about the Anthropocene is that it really began in 1610, probably the earliest date of measurable human involvement in global climate change. That year marked the low point of a decline in atmospheric CO2 due to the regeneration of millions of trees in lands that had been cleared for farming and settlements. Known as the Orbis spike, this temporary drop in CO2, as recorded in ice core samples, has been linked to the Columbian Exchange, the period in which people, animals, plants, and disease were transferred between Europe and the New World of the Americas. Dominated by European explorers and exploiters during the 15th and 16th centuries, the exchange marked not only the birth of modern colonialism, but something even more lethal: the introduction of smallpox and other diseases for which the native population of the Americas had no immunity. More than 50 million natives died as a result. Nearly all of them had been engaged in farming and the clearing of forest. The resulting abandonment of their farms over massive areas of the Americas allowed the widespread regrowth of forest, which in turn sequestered large amounts of carbon as they grew. Thus, humans, or the loss of them, may have produced the first global marker of the Anthropocene. It's taken another 4 centuries to tease out the many ways in which human energy choices add to global greenhouse gas concentrations. But it is plausible that the human fingerprints on climate change, and hence on the Anthropocene, are more than 400 years old. Sometimes it feels like we are still lost in a jungle of contradictions between our technological know-how and our addiction to fossil fuels. In order to avoid the worst consequences of accelerating climate disruption, our society must limit increases in average global surface temperature to less than 2 degrees Celsius above pre-industrial levels. This goal, known as the guardrail, requires an 80% reduction of global greenhouse gas emissions by the middle of this century. But some studies conclude that a goal of 2 degrees Celsius is dangerously high, and that we should be aiming for a lower and more demanding guardrail goal of 1.5 degrees Celsius. A half a degree could mean the difference between a world with coral reefs and one without. Regardless of who's right, both goals require an unprecedented rapid transformation of society. The needed emissions reductions can only be achieved by a combination of alternative energy sources and efficiency improvements, along with revolutionary breakthroughs in atmospheric carbon capture and long-term storage. An alternative approach would treat the symptoms instead of the disease by employing so-called geoengineering strategies designed to reduce incoming solar radiation without limiting greenhouse gas emissions.
This might, for example, involve large numbers of aircraft scattering large quantities of particles, such as sulfur dioxide, into one specific layer of the atmosphere, namely the stratosphere. The particles would then act as a reflective filter, throwing a percentage of solar radiation back into space, and thereby preventing it from heating up the atmosphere in the first place.
Its cost advantages are, at first glance, incredibly seductive. Dispensing sulfate aerosols high in the stratosphere could slightly cool the Earth for a mere $8 billion or so each year. But it would trigger large uncertainties about unintended side effects and malevolent applications of the technology as a regional weapon of intense weather and climate modification. And even with rapid deployment of such strategies, CO2 concentrations would continue to build, harming the ocean. Moreover, adaptation to other changing climate conditions already in the pipeline would still be necessary. Humanity seems poised to discover that the perpetual growth agenda propelled by cheap energy in the 20th century is about to suffer a head-on collision with the 21st century's limits to growth agenda, which is powered by nature. Of all the variables affecting future climate, energy choices are by far the most important, and at the same time highly constrained by the fierce intransigence of powerful stakeholders in the fossil fuel industry. More than 3/4 of human greenhouse gas emissions come from the energy sector, almost all of it from the burning of fossil fuels. The path to a lower carbon or net zero power supply is increasingly dependent on efficiency improvements and renewable energy development, especially wind power and photovoltaic technologies. While nuclear power has its ardent supporters, the fact is that the rapid decline in installed cost of wind and solar have not been matched by progress in nuclear power. While it is probably true that nuclear power risks have been overstated in comparison to the known health and environmental risks of coal, oil, and gas, the once vaunted role of nuclear in the energy supply mix has been steadily losing ground to renewables in most of the world. Although the intermittent nature of wind and solar are significant disadvantages, advances in battery technology and other energy storage options continue to show promise. That said, decades of solar development have only now surpassed the 2% level of global electricity supply. Electricity from wind has penetrated faster, now about 5%, but it should be emphasized that for all of the economic success in renewable technology, the dent being made so far in the climate problem is very small in absolute terms. In 2018, coal added more global electrical generation than any other single energy source. Without directly pricing carbon emissions, say through a carbon tax, the technological breakthroughs achieved in renewable energy are unlikely to be either fast enough or at sufficient scale to avoid going over the climate guardrail. In other words, while moving quickly from 2% to 10% of global electricity supply would make the solar industry ecstatic, in a world that is also burning 80% more coal than it was at the beginning of this century, the net gain in climate benefits would be nearly invisible. In fact, some critics of corporate capitalism wonder if renewables are essentially propping up the same ill-conceived economy as coal, oil, and gas, making ultimate solutions to the climate problem even harder. Annual global carbon emissions from energy-related sources have been growing by about 1% in recent years, which is a major reason why expected gains in efficiency and renewable energy will not be enough to meet the 2-degree guardrail, let alone the much more desirable 1.5-degree goal. Meeting either of these goals will probably require major emitters to phase out fossil fuel subsidies, to put a price on carbon, and to devote more attention to fugitive emissions of methane and other key industrial chemicals. Harder still, carbon capture technology will have to achieve large-scale breakthroughs by sequestering immense quantities of existing atmospheric CO2 for very long time periods at relatively low cost. And that is assuming we can end the problem of global net deforestation, a major source of atmospheric carbon. The leading alternative to conventional carbon capture is called BECCS, and the Paris Climate Accord relies heavily on its future success. The problem is that relying on bioenergy may not be as scientifically sound as it is politically expedient.
Large areas of land would be turned into plantations for fast-growing monocultures, trees or crops selected for their ability to extract CO2 from the atmosphere. To meet the targets set in Paris, however, huge areas of land would have to be set aside. Indeed, the surface area required has been calculated to be that of India at the lower end and twice the amount of land currently used for global agriculture at the upper end.
Regardless of the chosen energy strategy, decision makers everywhere will need to internalize environmental cost and to adopt the concept of energy returned on energy invested, EROI. Clearly, the ratio of energy expended to energy produced and delivered is a key consideration in energy economics, as is the choice of discount rates used in energy benefit cost analysis. The fact is that only hydropower and some types of wind production can promise a truly high EROI at present. Coal is next, mostly because all the cost of making it over millions of years were paid for by nature, and it happens to be very accessible. Solar technology cannot hope to compete with the energy content packed into fossil fuels. Nearly 300 million years went into concentrating their production. We need to acknowledge that the renewable advantage is in sustainability, not in energy density. That means we will have to become smarter, more efficient, and resilient in how we use energy. Although the energy sources themselves may be inherently much cleaner, the end uses for which they are harnessed must be chosen more prudently and sparingly.
The essence of the climate challenge can be captured in a single question. Will we be able to transform our global economy, which was designed to be powered by artificially cheap fossil fuels, into a green economy in which human-added emissions of greenhouse gases declined sharply within the next 2 to 3 decades? Unfortunately, the answer to that question depends on the answer to a related question. Will human beings accept changes in their cultural identity that move them away from an anthropocentric to a more ecocentric worldview, one that diminishes the urge to dominate nature and to overconsume non-renewable resources? Without transformation of human cultural identity, there can be no lasting transformation of the economy in a way that sustains diverse life on this planet, along with a resilient human civilization. Unfortunately, fears about civilization, diversity, and ecosystem health are not sufficient concerns to motivate most people to take strong climate action. Even worse, many people foolishly believe that ecosystems are expendable and that wealthy humans can buy themselves out of most climate risks and societal consequences. The fact that water, food, and energy costs are expected to rise as climate impacts grow does not seem to alarm many of them, nor do the added cost in insurance, climate-related health care, and lost productivity due to extreme weather events. Only the prospects of mass migration of climate refugees seems to sound an alarm. And even that can be avoided with enough wealth and illusory walls, but some combination of climate refugees, pandemics, submerging coastal cities, mass extinctions, and Category 5 hurricanes may shake public confidence in the wealth and walls strategy. In fact, funding walls to keep out refugees will have to compete with horrendously costly seawalls. At that point, informed people will realize that climate-driven defensive expenditures in the trillions come at the expense of healthcare, education, the arts, and all the other productive investments that an enlightened civilization happily requires.
The sad reality for would-be climate winners is that their wealth will only permit them to lose more slowly than the immediate victims of climate disruption, the global poor, who are concentrated primarily in what is called the Global South. Climate justice issues are becoming the greatest test of our collective morality because they will affect more people, plants, and animals for more centuries and in more irreversible situations than any other moral quandary we face. Climate change may lead to the largest refugee crisis in world history. Some relief organizations worry that the number of global climate refugees could reach 1 billion by 2050. Others, like the World Bank, project the numbers will be closer to 200 million. Either way, wrenching dislocations in the management of the Anthropocene are all but assured without strong climate action. Add to this the dislocations implied by mass migrations of animals and plants as they move toward the poles and upward in elevation. We are only now awakening to what lies below the tip of the climate iceberg. The key lesson in all of this is that climate disruption, like ocean acidification or mass extinction, are all symptoms of a bigger malady. A human-dominated planet that has moved from the local to the global impact level. Until we deal with the forces that created the Anthropocene, we will lack the ability to attack these interlocking crises in a coordinated and effective way. Quite simply, we will lack the capacity to secure our future.
Artists have developed a powerful way to visualize the Anthropocene using blocks of melting ice that have been arranged to spell out the future. The resulting picture is surely worth 1,000 words. It reveals how climate change is clouding our future, if not literally melting it away.